Now, you were asked to show that if the vector xi plus yj plus zk is perpendicular to the vector 2i plus 5j minus 3k, then 2x plus 5y minus 3z equals 0. You're just asked to show that. But when you're asked to show something or prove it, you automatically, I think, assume that it's difficult. Well, in this case, you simply take the statement of the problem and write down what it means. Okay? If this is perpendicular to this, then the dot product of this with this is 0. So, we could put an intermediate step here. This is true if and only if dot product is 0, which is true if and only if, well, write out the dot product and set it equal to 0. That's it. People got a good laugh out of this when they realized what they had failed to do. Okay? So, very straightforward. And in many cases, what you're allowed to ask to prove is very straightforward if you can just write out what it means for what you're trying to prove to be true. Okay? Now, the other problem, you ask if the ask to show that the vector from 2, 3, negative 1 to x, y, z is perpendicular to the vector 2i minus 5j plus 3k, provided a certain equation holds. Okay, and the equation I've got written down here somewhere, pretty much this equation. Okay, this is the equation you get if you just write out what this means, and this is completely equivalent to the form of the equation as it appeared on the paper. Okay, and it's very easy to figure out what that ought to be. Okay, the vector from here to here is perpendicular to this, which means that the dot product of the vector from here to here with this vector has to be 0. Well, what do you have to do in order to test that or to write out that condition? You have to know what the vector from here to here is. Okay, well, if you know how to get the vector between 2 points, and there have been a number of problems that have asked you to do that, it's very easy to do, and you get an easy picture. It's just, it would be this, the difference of the x-coordinates times I plus the difference of the y-coordinates times j, excuse me, plus the difference of the z-coordinates multiplied by k. And I've got a picture down here that kind of depicts it. If this is your point 2, negative 3, 1, and this is your point x, y, z, then you have this rectangular box within which the vector is the diagonal. Okay? And that means you move over some distance in the y direction, you move some distance in the x direction, you move some distance in the z direction, or through some displacement in each direction if we want to be really technical. And we probably do. The change in the y-coordinate is going to be the length of this side. Well, that's clearly going to be the y-coordinate here minus the y-coordinate here. Y minus negative 3 or y plus 3. Distance in the x direction is going to be x minus 2. Distance in the z direction is going to be z minus 1. So that this vector is x minus 2i plus y plus 3j plus quantity z minus 1k. Now all we have to do is say, okay, well, if the vector from here to here is perpendicular to this, well, this being the vector from here to here, the dot product of this with this should be 0. So we write out what the dot product is. First we say, okay, well, and I state what I just said. This vector here, perpendicular to this vector here, is equivalent to dot, 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 and that's an ellipsis, and I'm simply leaving out the statement that the dot product is 0, but that's what it is. That's a condition for perpendicularity. And the dot product of these two vectors is what? X minus 2 times 2 y plus 3 times negative 5, z minus 1 times 3. Now you have to rearrange that, like put the 2 in front here, put the negative 5 in front here, put the 3 in front here, and you get the form on your paper. And I hope you have the initiative and see how easy it is to do that after you've done it a couple of times. Okay? Now I can also say that, and I kind of digress a little bit here, or anticipate something that's coming up very shortly. If I expand all this out, I get 2x plus 5y plus 3z minus 22 equals 0. And that's completely equivalent to the form of the paper, which is completely equivalent to this, which is completely equivalent to the dot product being 0, which is completely equivalent to this condition, which is completely equivalent to what you were asked to do in the problem. So that this equation here is the equation that says that this vector from here to here is perpendicular to this vector. Now, as demonstrated, if I have this vector, so let's just say that that's the vector, okay, from here to here. Actually, I want to not use this vector. I want to use this vector. Okay. So this vector actually is in this direction, but I'm going to pretend it's in that direction. Okay. To say that the vector from here to here is perpendicular to this is to say that, well, if I start from this point, let's just say the crux of my elbow, move into the camera a little bit, from the crux of my elbow, we do this vector. And now we do a vector perpendicular to it. Okay? Now, this vector, if I've got the right angle to my forearm, is perpendicular to this vector. If this is the point, what is it, 2, negative 3, 1, okay, the point here is 2, negative 3, 1, then this point out here would be the point x, y, z. Okay? So this vector represents this, and this vector represents this vector. And any time now this vector is perpendicular to this vector, I've got a vector that satisfies the condition. Okay, well, there are infinitely many such vectors here, here, here. Okay, I can actually rotate this vector around a circle. Can't really do that because I got joints, but the vectors that satisfy this form a circle around this point. And those vectors could be any length. You don't know how far x, y, z is. So the points at the end of this vector, which are your x, y, z points, could be anywhere on a set of concentric circles around this point, those circles being perpendicular to this vector. Well, all those circles expand out to form a plane. So there's this plane perpendicular to this vector at this point, and this is the equation of that plane. I'll talk just a little more about that because it anticipates something that's coming up probably in the next class.